FRQ4 of the 2025 AP Calculus BC exam. Part A, they want us to find g prime of 8. Recall this definition of g of x. So if we want to find g prime of 8, we have to first differentiate g. On the left, g obviously differentiates to g prime, but on the right, we have integral of f of t. So if we differentiate an integral, they cancel out, and so we just have f of x. Yeah, so we know g prime of x equals f of x. So g prime of 8 equals f of 8, and we see on the graph f of 8 is 1. Part B asks, find all values of x in the open interval minus 6 to 12 at which the graph of g has a point of inflection. Remember, when we want to find points of inflection, we need to see when the second derivative is equal to 0. In part A, we already established that g prime of x equals f of x, so if we differentiate this again, we have g double prime of x equals f single prime of x. So we want to find when g double prime of x, which is f prime of x, equals 0, or when this graph has a flat tangent line. And we see that it attains it right here and right here. Because of that, the points of inflection are x equals -3 and x equals +3. Part C, they just want us to find g of 12 and g of 0. The g of 12 is, using this definition, we have the integral from 6 to 12 of f of t, or the area under the curve of f from 6 to 12, which is this triangular bit here. You can find the area of that very easily with 1/2 base 6 times height, which is 3, which gives us that g of 12 is 9. Similarly, g of 0 is the integral from 6 to 0 of f of t. But these bounds don't make sense because we're going from high to low. So instead, we have to flip them by adding a negative in front. So we have negative integral from 0 to 6 of f. The integral from 0 to 6, or the area under the curve of f from 0 to 6, is just this semicircle here. So it's 1/2 pi r squared. So that makes g of 0 -9/2 pi. Finally, part D wants us to find the value of x at which g attains an absolute minimum on the closed interval minus 6 to 12. We're looking for the extrema of g, which we would find by differentiating g and setting it equal to 0 to solve for the critical values. We need to find when g prime of x, which is f of x, equals 0, which is here, here, and here. We have 3 candidates for the absolute minimum of g, and we can rule some of them out by looking at the behavior of g prime. For one of these points to be a minimum, the derivative g prime has to switch from negative to positive at this point. We can't use this to check this one because this is an endpoint, so we'll just have to directly compute this value. Here, the derivative does go from negative to positive, so this is fine, but here the derivative goes from positive to still positive, so we can rule this one out. So we just need to find g of -6 and g of 0. We have g of -6 is the integral from 6 to -6 of f, but that doesn't make sense because we're going from high to low, so we're going to flip the bounds by adding a negative, so we're going from -6 to 6 of f of t. Watch what happens here. From -6 to 0, we have this negative semicircle. But then from 0 to 6, we have the exact same semicircle, but positive. So this area and this area will cancel each other out, making g of -6, 0. And we found in part C that g of 0 is -9/2 pi. As -9/2 pi is less than 0, g of 0 is the minimum, so our answer to this is x equals 0. And that's FRQ4. Let me know in the comments if I made any mistakes, and be sure to check out the rest of my page for the last 2 FRQs.